By now, we're all familiar with how important medical imaging is for the visualization of structures within the body. We know that it is commonly used to diagnose and treat disease. But what if I told you there was a way to utilize these standard medical images to extract quantitative information? This quantitative imaging information, used alongside machine learning and with the integration of clinical, genomic, and dose distribution factors, could provide a more comprehensive view of diseases. The field I'm describing is known as radiomics, and it aims to develop, evaluate, and translate clinically relevant image analysis tools to support diagnoses, treatment, and response assessment in oncology. Quite generally, the process involves acquiring medical images through CT, PET, or MR, identifying the tumor volumes and segmenting these regions of interest, extracting radiomic features such as shape, size, and texture that quantitatively describe the tumor volumes, collecting large data sets, and finally using machine learning to find patterns within these large data sets. My lab is looking into using radiomics on the planning CTs of oropharyngeal cancer patients treated with radiotherapy. Oropharyngeal cancer is the most common head and neck cancer, and radiotherapy is the definitive treatment. HPV is strongly associated with the cancer, and its incidence has become more prevalent over the past 2 decades. In fact, 70% of oropharyngeal cancer patients test HPV positive, with the majority of these patients surviving with good outcomes after standard of care treatment. However, approximately 15% of these patients still remain with poor survival rates and will develop a recurrence post-radiotherapy. Currently, there are no clinical prognostic factors to determine which patients are at a higher risk of recurrence after treatment. Therefore, we have an unmet clinical need in being able to identify these patients in the image acquisition stage before treatment. An accurate imaging biomarker would be able to predict beforehand which patients could benefit from a higher radiotherapy dose or a treatment plan adjunct with chemotherapy. Therefore, the goal of my study would be to build predictive models between image features and clinical data, and in turn develop a machine learning classifier to improve risk stratification. This non-invasive tool would be the first of its kind to integrate information from medical images, patients, and their treatments, leading to more personalized treatment options and ultimately improving outcomes for cancer patients. Thank you.